Hello friends, how are you? I hope all of you are good and doing great. So in this today's video, I'm going to talk about my recent project I have done for machine learning in uh, its end-to-end project of insurance charges. So let me start that to show you that what is actually all about. So in this project, I have done that Healthify insurance charges prediction. So it's an end-to-end project where we have the data for peop various type of people, various age of the people, and having us means with different BMIs, how many children, whether they smoke or not. So means it's just a prediction that if they have to go for their rest of the life for their premium charges for this insurance charges, that how much it would be. So this is how we have, this is one we have to predict. So instead of going through with this notebook in GitHub, I already committed everything here. I have completed this project. So let me go through and I'll let you know. I'll also run in front of here in that so that you know that how it's working. So Google Colab, and then let me open it. I already saved it in my Google Drive. So let me open it from my Google Drive. Open notebook. So this is the one just now I saved a few minutes back. So the thing is, we'll also uh, by achieving this objective, we aim to achieve the accurate and personalized insurance charges estimation, reducing the cost of underprice and overpricing, improve customer satisfaction and loyalty through air and predict competitive price, ensuring transparency and compliance with regulatory requirement in price strategy will further strengthen our competition position in market and enhance our overall business. This is our final goal. So basically this company has to improve in their business and all. So we have the data available for the various. So how we'll do that? We already have this file of for this file is already there in my, yeah, is this insurance.csv file. I already have the file, yeah. So I'll also have to upload this file in my Google Drive in Google Colab now. So first of all, we'll all just define all the import libraries like pandas, sklearn, joblib, matplotlib for EDA purpose, cbon for again for matplotlib, or for graphics and for graphs or charts, for histograms basically. uh, will This is not required, that sklearn open module one open. This is required if you'll have this another modules is from fetching directly from the sklearn. So we sklearn itself have there are lots of inbuilt, or there is a lots of data sets is available. So in this particular submission we don't need it, but yeah, we for our prediction for doing that testing and we need and basically to fit or creating a pipeline, we need a standard scaler, one hot encoder, and creating a complete pipeline, simple imputer, and make column transformer pipeline. So these are the things we needed, and also selection of for our algorithm, we'll using a test train split and then random search CV. And we don't need a logistic regression, we need a linear regression here. So this line is not required, since again linear search is enough for this. We'll use that. So let me start this one. So configure sklearn to display pipeline diagrams for visualization the structure of machine learning pipeline. So just populating the data or loading the data in the data frame. Let's see first pipeline. You can see that there are pipelines is basically indexes. There's a column indexes, age, sex, BMI, children, smoke 0 or 1 means, sorry, children's, it could be multiple more, around 0, 1, 2, 3, 4, 5. So the data have around max 5 children's, and it smokes on yes or no, region, northwest, southwest, southeast, northeast. These are the column data for the regions, and the charges. Sex, male or female. BMI could be anything. Data is a number data. Age is a number data. Yeah. And then if you print that, again the same thing. Here we have print the sample 5, first 5 sample. Here we have print the head. So data description, as I told, that it's a unique identifier. Index is a unique identifier. Age is basically a customer. BMI is body mass index. Children, number of children, dependent covered by the insurance. Smoker indicates if the customer is smoke or not. Region basically of customer, northeast, southeast, northwest, and southwest. Charges is estimate based on the prediction, or the based on their data. So this is the data, as I told, that we have around 3 integer, 2 float, and 3 categorical variable inside this. So let's divide the data is basically in target variable, numeric features, and then categorical features. So let me close this one. So I hope it's fine. And then we have the data shape. So we have around 1338 number of rows, and data sets is count, the number of column is 8. So this is again, are there any nulls? There are no null values. And basically these are the numerical features. So it's the other one is a categorical feature. So age, BMI, children is a number variables, numerical features. And then categorical feature is basically sex, smokes, region. So children's counts of the children with the 0, every distinct values of each age is basically, it's like the children's is 0 number of children's. There are customers or having out of this the given data 574 people have that no children's, and 324 have 1 children, 240 is 2 children, and 157 of 3, and 25 customers have 4 children, and 18 customers also have that 5 children. So let's again see the data for the numerical and numerical data and categorical data. So we have age, BMI, and children, and number of the charges. Accordingly, for categorical data also, we can see that it's female, male, or sex wise, or smoker, yes or no, region wise, southwest, northwest, and until that at the end. So as we have discussed already. So it's a statical data. It's basically, it's similar like describe of the data. So basically it's for the numerical features, we have age count is 1338 total number of, so for age count is for same for all the columns. So mean values for the age is 39, BMI is 30, and children is 1, and charges is there. So it's very much clear that what is the mean value, how many are, basically we have to find it. If we need to find out the outliers and all, we can find it out. So I'm not wasting much time on here. I think it's quite easy and understandable, and I'll also put this in my GitHub URL, and then can be easily can be available. So this is again, I'm putting the insights out of this. So age, the data range from minimum age is 19 and maximum age indicate the diverse age group in the data sets. BMI, the value range from the minimum of maximum indicate variation in the body mass index among the individual. Children, the number of children range from 0 to maximum. Suggestion to mix individual with or without children. Children charges vary significantly with the range of minimum and maximum value. Further analysis is needed to understand the factor influencing the charges. Categorical variables data, basically its sex is basically the data sets includes both male and female individual with no missing values. Smokers, basically smoker, the data set it contains information about smoking habits with yes indicates smokers or no indicates non-smoker. Region is the data sets include the individual from the different region, namely southwest, southeast, northwest, northeast. Charges, the charges variable represent the insurance charges of the individual. The statistical summary provide oh sorry, it's my Google, uh, it's triggered, sorry about that. Yeah, the statistical summary provides information about the minimum, maximum, mean, and quarterly wages, giving on overview of distribution of insurance charges. So are there any missing values in the data sets? No. Are there any duplicate rows in the data sets? No. Data is again duplicates. If there is anything, you can use this values. So this also can be used in the other for the other data sets. The way I have prepared it can be used for all these others as well. So if there is any columns or anything is duplicate, I'm just dropping it. So in this in this data there is no nothing is duplicate, so it will not drop anything. Only I'm dropping the index column because it's not needed for my data analysis. Now let's do it for the EDA part. uh, I'm just displaying the histogram between data distribution between charges and based on the sex. So you can see that it's for if the for the number of count for the males is high and the charges are also high, and for female the charges are also low as going. So the data is skew data on the right hand side. So it's basically if it appears that the charges for the male and females are same, however there are more males than females with the charges of exceeding values. So distribution based on basically age distribution, based on age distribution. So this is charges based on the age distribution. It's very lenient. There is no drift, no much, not much changes are there. This is based on the smokers, smoking or non-smoking. So again it's basically yes is basically the charges for if the person smokes, then the charges are high. If the person is not smoke, there are people with non-smoking, the charges are comparatively less. So again based on the BMI, charges based on the BMI, it depends on the people are basically with the different age have the different BMIs. So this is based on the average BMI is like this for every age. So this is again based on the age and charges. So there are three groups. If I see that it's basically it divided into three layers. You can see the data is divided into 1, 2 and 3. These are the three sets is divided. Now my part is I have to do that model estimation. So again I'm dividing the data into, again I'm defining the target, numerical features and categorical features. So for my x and y I am saying that x is my numerical features and categorical features are basically my x, and charges is comes under target variable. So I'm again splitting the data into 20 and 20% and 80%. So now this I'm creating a pipeline, and this my pipeline is basically I'm using for categorical variables. I'm using imputers, simple imputers, and for and one hot encoder. So this is I have done that in the pipeline. Yeah, and then I am using a preprocessor for numerical features is standard scalars I am using, and for categorical features, I am using one-hot encoder as I told earlier. So in this, if you want to see that how it's happening, so you can also print this preprocessor, so you will get some idea that what is happening. So in the preprocessor we already have that column transfer, basically one-hot encoder and then standard scalars. So one and model linear transit regression. I'm using this algorithms and creating a pipeline with my preprocessor and model linear regression. I'm fitting this data into my model, and then evaluations. I'm just predicting the values based on my model for the X. So it's the training is already done for based pipeline is fit basically for X train and Y train data. Now I'm predicting the values based on the X test data. So these are my RMSE value and R squared values. These are the required values for the linear regression. So now I am doing a serialization. Serialization, I think I have already explained in my previous video where I have done for the machine failure prediction data. So in the similar way, I am just checking the version numbers, and now I am writing my all requirements and everything, or my train pipeline and app.py, all the files inside in my Google Colab itself. So if you see here, currently I don't have anything, just refreshing. Now I'll try and I get that my requirement file and then my train.file. So train is the train.py file is nothing but it's all everything whatever we have, it's above in my above whatever I have done for the training I have done here itself. So you can see that my requirements and the train py file is ready. Now just execute that train.py so that I'll get the data. So let's see. So R squared data is coming as 78% and model, and it's basically estimating model pipeline. These are just print and serializing the model. So now next is prediction. So it's a save model. So just loading the model. So I am just saving the model here. So you can see that my model is also saved here in. So these are the files I am going to use for my deploying when I am deploying it in either in local or in Hugging Face. So again I need this Gradio file. So first thing I need that I need to in the data sets I am just using this code to get the distinct value for each column in the in my file CSV file. So for the indexes, these are this 1 to 0 to 13375 number, so there is no use. Age wise also I don't need. For sex is basically male and female. BMI also don't need, it's just a number. Children, we have, as I told, we have maximum of 5 children, so I need that value in the drop down, or I need as a number. So smoker is yes or no, I need it in the drop down. And southwest, northwest, these are the regions, and northeast and southeast. Yeah, northeast and northwest. And distinct value for charges is also no use. So these some of the values are 3 categorical variables, or and children I can use it as drop down. So in app.py file I have written the code everything here. So first thing is, it's if there is any changes in the data, it's first thing it will just check the in the train.data, it's check that okay, if there is any change, it will just run through my data and give me predict it and check the RMSE value. And then the next thing is basically I'm just using this again model, I'm creating a model file things. This is not required here when we am doing it in local, but it's required very much, and I am using it for my Hugging Face deployments. I'll create a data sets and I'll so that I can find out that data is basically it's whatever data has been tested, I can also use it in my testing purpose. So I forgot to discuss about the import statements. So basically OS is operating system, UUID basically in which it's running the file, is in system or device. It is then we need a UUID number, and JSON basically we'll have to, when the output is ready, we will have to save the data into the logs. For that I will convert the data into JSON format, everything. And then we have Gradio is basically for UI. Pandas is basically for the end-to-end while I'm using the train.py. And Hugging Face hub, basically I have to put that everything in Hugging Face. Then we need a dataset connection and creating a scheduler. For that purpose we needed Hugging Face. So path lib is basically we need when we need to load the path of the log file. Yeah. And then predicting the charges, insurance charges, I'm just taking the all the values, required values. I'll have in the UI, I'll have age, BMIs, children, sex, smokes, and region. And then I'm just putting it everything inside that and predicting with the help of model. So this is basically nothing but it's predicting, calling the model, and inside that it's getting the values. So this is again every after 2 minutes the scheduler will run, and it will, as I showed here, every 2 minutes there is a scheduler will run and it will put the data inside this, and the prediction will be written. So in the UI we'll have a age input, BMI input, children input as number, sex as drop down, and smoker as drop down, region as drop down. And then for model output we'll have that, I'm showing that it's basically a label only, this one. And then it's the heading for this label is basic healthify insurance charges prediction of the cost for medical insurance. So in the interface we'll have everything puts as inputs. We have these values, age, BMI, children, sex, and then title side we have this health insurance and everything, and description, allow flagging and example and concurrency. So this is examples will be basically, once we'll have to in Hugging Face. The thing is, in Hugging Face when we do the deployment, when we commit this app.py file, it will start immediately the deployment in the container. So that time the first thing it will check that this data against my model, and it will immediately give the results and before starting, so that you also know that everything is working fine before hand itself. So okay, I don't need two files. It's one file is enough. It's similar, same thing. I'll delete one. uh, okay, I'll delete the above one. It's same. I don't feel any differences over here in BMI. Okay, I know. I'll remove the above one. So it's similar. So it's no difference in the same. It's same. And yep, it's same. So now we have to do this inferencing. So inferencing basically, okay, now the thing is, since we have ready with these files, we can do the deployment in cloud. So for that I'll go to my Hugging Face. I could do in local. So local also I'll show you how I have to do that. Let me do it. I already have this running in my local. Let me create one more data sets for you so that you will know that it's working or not. Okay, I say that insurance charges, and then create anything. I just take it MIT, and then create the data sets. I'm not sure, there's a one problem was going on. Yeah, so the same issue is same. So for to resolving this issue, I'll have to go to my readme file, and I'll also open that one more Hugging Face, and I'll go to my one of my previous or any running. I'll take the everything from here. So I'll edit. No need of edit if you don't see that is required. I'll copy everything except the name, and then I'll go here and edit. I'll put this color to green so that I'll not got confused. So everything is saved, and then just update. So my thing is ready. If I'll go here in app, I can see that if everything goes fine, without we'll not have that issue, then we'll get this one at the first place. Now let me upload my files. Upload. So I already saved it here in my repository, so I'll take the files one by one, like this one, this one, this one, this one, and this one. Okay, and then just open it. I'll not upload this app.py, so let me upload rest everything first and check once, and then I'll do that. So let me check if it's required. We don't need this Gradio and this job lib because it's inbuilt. We have already selected while we are doing this creating the space, Hugging Face space. So now we have this. Now let me take the file, my app.py file. You can download those files and you can use it. Hence basically I have already done that, so I am not using it now. So if you have any issues in doing this, any steps or anything, since you can see that since I have, as soon as I have start the upload the app.py, it started building. Since I was using this file for my local, so it's in local, my scheduler and my logs will not work, but however it's working for you in case of your if you, since you will copy and paste everything from there. So now it's, you can see that the building is happening now. My all builds and everything is done, all my dependencies and everything is downloaded. So in the sklearn was the only file which is there required, but since it is doing that configuration is already set in the Hugging Face, so it's download lot of files. If you feel that I'm talking too fast, you can reduce the speed. If you feel that I am talking too slow, you can again increase the speed of the video to that you can understand, or you can watch it and take the most of out of it. Another thing is basically it's I say that after this I have to do a inferencing, batch testing, and all these things. So users will not test one data every time, and since they have the thousands of data inside it, so they will test it's one shot. They will not use it for uh, one one data at a time. I also need my Hugging Face uh, sorry, not this one, my Hugging Face token copy for write. It has write, read, so we need, for this purpose we need a write one, and then I also have to do here this required when we'll start the scheduler and everything. Okay, here value hf underscore token, save it. Let's see if my deployment is done or not. Still in progress. The first time it will take time, obviously. I hope the deployment would be fine. If not, then we have to debug it. So if you really like my videos and and feel that it's work for you, then please share it, subscribe it, and like it. Yeah, and so that I'll be motivated and I'll prepare this kind of videos more and more. So I am also I if you noticed, I have also done some of the things for other models as well. I am already working on text summarization, YouTube. I'm also working on others as well. Like we have, uh, I'm keep on doing this deployments for Hugging Face for another until few more deployments like this. I'm using it for Gradio only, but I'll also do that for the my Streamlit as well. So you can see that it was showing in the log. It was showing that example 1, example 2, example 3. I already have that. So you can see that examples, and here also it is showing it here. So let me put some data. I put that age 30, around 45, BMI is 34, children around 5. I'm putting everything max, and it's male, yes, smoke, and region I'll put anything, and then submit. So it's giving me the charges. So it seems it's working fine perfectly, but now I have to do that scheduler. So I already have the data set available, but I'll not use this for this one. Basically, if you see that I already have one data set, insurance charge ML ops log. So I'll do some changes so that the data will not go into this one. Okay, let me go here and create a new data source and go inside this insurance charges. So this one I need somewhere. Let's okay, and then in app.py I have my logs as insurance. I'll not put mlops now for purposefully. Okay, edit mlops. I'll not use. I'm saying that only insurance charge logs. So I'm giving this name a license wise. I'm using MIT create dataset. So now my dataset is ready. Now I'll let me uncomment the date things here. This one uncomment, uncommented, uncommented, and then let me uncomment this one. So this one also done. Again I'll just commit it. So as per thing that my whenever if everything works fine, then if I'll enter the data from my UI, after if everything fine, then it will the data will be loaded into my this data set. So currently it's nothing. This video is going to be long a little bit more because I am also doing the inference, batch processing, and evaluation, and everything in this in the exact one video. So everything seems fine. Deployment is done successfully. So I believe my logs will be also there in inside this now. I'll put that 32, 33, number of children 3, a female, no, submit. So yes, I am getting my data. Age is my 45, and then BMI is also 45. It's too much. Person would be die if I'll have this 5 children's, female, smoke, yes. I'm putting the totally different data and then submit. The charges is again coming. So let's see if the data is reflecting here. Takes time, 2 minutes time. Let's give the 2 minutes time. So this I have it, my insurance charges. This is I need inside it. So if I'll say that my this one is I'm not changing anything here. So the next thing I'm doing the testing of the data, and then we'll do the inference. So here I'll comment this one, and then I'll use the new one, and then creating a client. So far we have done until this, everything executed. Let me execute this one again. Okay, let's see the data is there or not. I have inserted 2 rows. Yeah, so I have around 3 when we have do the deployment, and then the 2 rows what I have entered. So now let's do the rest of the part. So in the inferencing we have to just say that the Gradio, and then this one, everything again I'm doing it, and then testing data. Basically again I'm doing the tests for this is for the test, dividing the data into x and y trained, and defining the target, numerical and categorical variables, and then extract shape. So for the test one we have 262 to 268 rows. Headwise is basically you can see that how we have the data 764 index and 887 and 894. BMIs and x test is I'm defining like this, and then location for this particular row I'm just checking this one, and sample 100 samples I'm checking and doing it this one, then sample 0. So sample 100 and sample is like this. Inferencing I'm just connecting to client. Okay, this one is not happening. So it is calling my Gradio client. Unexpected index. So it's Huggingface. I have already given that. So it's checking my space. Now predicting one value, giving the data and just predicting it. So this is done. This is my prediction value. I'm also giving one more data. It's some predicting values. So now first thing I'll have to, since in the sitting in office I cannot have to do that all this data one by one entering. So in clients basically they need something to be batch to be run. So just creating a batch of 100 and just executing. So this is basically a complete end-to-end testing will be happening for the uh, data of, it could be 100, it could be 200, it could be multiple. So it uses is it just a backend, or from the uh, like I'm doing it in Google Colab, they can also use as developers, or basically a client can do that. So once it will complete, it will be on 100%. I'm also doing the unit testing in this, and also perturbation, and then edge cases. I'll come, I'll also tell that what is the edge cases, and then the monitoring. So I'm doing that all these things here in this. So it's still half of it's this uh, complete notebook, it's remaining. So around 2 or 3 times I'll be doing this 100% batch processing kind of a thing with the different data. This time I'm doing for the trained testing data. Next time I'm doing it for test data. So 30%. So once this is done, I'll have to save this. So there is a code in, I have tried to basically trying to do this, converting this IPVNV file into HTML with the help of this code, but it's not taking time. I'm not able to make it work, and it's taking time. So I'm using this one link. With the help of this, I am able to convert it. So I'll also mention this one somewhere here here to convert, I'll mention it, to convert IPYNB file to HTML. For converting. Please use below link yeah. I hope, let's see what is the status for my job. So it's 69%. It will complete fast. Let's see. So it's taking around 3 to 4 minutes. In the meantime, we can see that the data is increased or not. I believe we'll have the data here. It's, yes, we have a lot of data here available. So it's around 76 rows already inserted, and I hope soon we'll have the lot of data inside it in this insurance charges as well. Uh, so now let's see the first 10 rows of the batch is completed. Then we'll have to do the unit testing again. I am doing the same thing, and here I have to change the path again. So let me take it from here. Otherwise it will hit the old one. It's fine, old one also fine, but yeah, I don't want to do it because I'm doing it for complete demo and end-to-end demonstration purpose. So this time I'm doing for unit testing for the test data for the again same thing, defining the data into numerical, categorical, and features, and then creating a x data and y data, and then doing fitting it into this 20% for the test, and then to inside. And then this time I'm also taking a sample, and then for the sample I'm working. So this is the sample data I have, and then I'm just doing the prediction again. So again for this data also I'm doing this prediction, and I hope, let's see how much time it will take. I hope it's less than last time, saying 2 minutes 31 seconds. So this time I'm doing the prediction again against the sample data. So that is for batch processing. This is for unit testing. So the same thing I am repeating, and I'm just checking the RMSE value and an R square value. So let's see, the last time I got this in 80% and 58%. Let's see this time. And in the meantime, you can see that the total number of rows is 107. So it's also increasing. Whereas if you will see the data for the old one, you can see that MLOps one. So I have inserted around 2.44k 44k data inserted into this. You can see number of rows are lost. So yeah, this is already I have done before. It's going fast. So 1 minute is remaining, and then so estimate the accuracy of the test sample. Use RMSE and R square of measure to performance of the model. So this is basically to check the performance of the model. If mean absolute values or root means values, RMSE value, root means sample square error is lower than the existing baseline, human or previous modern version, we move on to unit test. So whatever case it is less or not, we'll do the unit testing as well. Or the another thing we can do, that we can skip this case. I think it's not much on this now, so we'll be able to do it fast rest of the things. So should be fine. RMSE values, R square values, it is more than 78%. So now perturbation, so unit testing we are doing, we're taking one data and checking the results. It's 32,000 for the, if age is 35, BMI is 32, and 3 children, female and smoker, yes, for that, and getting the prediction. This is again I'm testing for the another data, same thing. So it's basically now the number of children is really affecting, that number of children is 1 and the male, then the charges are very less. If in another way we have the female and no female and then smoking, so smoking or the number of children could affect the charges. So edge cases, basically we can say that the in the scenario of edge cases is that when the person is smoker, insurance charges should be high. Let's see if the model can recognize it or not. So yeah, and if smoker is yes, the charges is also, I'm taking the edge cases. Basically edge cases is the last thing, that okay, now above that age it's a risk of the company for to giving the insurance or not. So that's way I'm just taking the value. So if I'll put this value here in the this, you can find the written thing here as well, what I am doing it here. So in, so this one is the charges is around this. So if the person is not smoking, you can see that the charges is going how, the charge should be less, and if the person's number of children is also less, then the charges again will go down. BMI is also a factor. If I'll go for BMI is 25, then I think again the charges will go down. Yeah, so you can see that the difference, BMI, number of children, and then uh, about the smokes also matters. Let's see about the females, if the charge is affecting. So sex is not affecting the charges much, and now that identify that definite driftness in the model. Again I'm doing the same thing, and now I'm monitoring the values. Let's see, maybe I need to restart this my notebook, because there could be affecting of the previous data. Previous things are already there. Excuse me. Again I'm dividing the data into xtrain, itrain, and then prediction. Okay, so this time I have to take the logs one. So in the logs, just stopping this one because I have removed the MLOps. Just downloading the prediction logs. Let's see if it works fine. Okay, so I was telling that the settings on the above one could affect. So I'm just restarting my session. some values of the existing configurations and running is fine. Good, having an issue. So again, starting from this setup for the driftness, starting, not much remaining. Let's see how much data it is there. Generating train splits, it's all done. So now we have around 215 rows. Go for the production, taking the data, whatever data is already there now from the access, and just doing this, the data for the whatever is the users and entered the data like that. So whatever data has been tested. The drift, we can see the distribution of the target value and training values, distribution of predict target value and the deployment, and then we calculate the mean of training value, sample value, variance, and then drift, and then try to see that there is a drift or not. So we can see that from the graph itself we can see that there is no different drift. Yeah, and then the target check is there is no drift inside this, and some other checkings will be there. So every time it is coming as no drift. So for saving the values in this, we can check if we want to converting our values in the HTML, then we can convert it. Let's see, I think the same thing I have also done for my in my local as well. Let's see if it is running right now. Just reassurance. What I'll do, I'll open it. If it is open it, open. Huggingface, no. Here, and then I'll go to my insurance cost or something. Yeah, so I already have the steps mentioned here. So for that you need to create a conda. You should have a conda in your system, and then you have to activate this. So I already have activated. I will just click on this one. So in this I have copied all these files over here, and my this app.py file is also there. Inside my requirement I have added a job lib and Gradio, and the readme file also we have to do this requirements file. So I have already done this in the previous videos and other videos, and every video I am doing this. So just run it. So this code is also running in my local. So let me open it. So now let's see, 33 mi 33, and then children is 3, sex is female, smoke is yes, region is northwest, southwest. Yeah, so the similar way the data is everything working fine. I hope you like the video, and yep, for the support please share it, subscribe it, and like it if you like my work. Thank you very much. And everything I have already commented in my GitHub, so you can find it out in my GitHub profile as well. It's in insurance cost. So this is one more library I am creating it for all my Hugging Face and all the deployments. So this is my R&D work, we can say. So everything I am committing here, but I cannot give any guarantee that it's working fine or not. So I'm just mentioning over here that what it's working. So yeah, so whenever it's I ensure that it's working fine, I'm just moving it the final code over here in my my uh, repository. Yep, thank you very much. Thanks for your support. Thanks. Please share, subscribe.